All right, welcome to the Engineering Principles class for September 23rd. I see that many of you have written in the chat box and said hello or here or something. A few of you have not yet done that. Everybody, please do that. Okay, also, uh, I have looked at your submissions for the engineering specifications for the hydraulic system. Many of you did an excellent job. I haven't actually put scores on everybody. I just gave a quick glance at everybody first, and I'll go back later this afternoon and do a little bit more complete go through where I actually give you the scores. But I have looked at them. And so, like I say, many of you really did a superb job. There were a few problems. Let's talk about some of those problems. Number one is that a couple of you didn't submit anything. That's obviously a problem. You guys realize that engineers have to do assignments and they have to complete them on time. If you're working on some project that maybe is $100 million project that your company's bidding on, and if you don't finish your part of the work, they aren't going to meet the deadline and your company's going to miss out on a $100 million possible contract. You're probably not going to stay employed at that company if you are the reason why they missed the deadline. Okay, so you have got to get in the habit of doing stuff on time. Okay, some of the submissions that I saw had a great drawing, but then there were no pressure calculations anywhere. Nothing to tell me how much pressure the pump needed to have for your to go with your cylinder. Others of you were the other way around. Others of you gave me the calculations for your pumps, but I didn't see a drawing anywhere of how the wires get hooked up. One person did the calculations, and this person said, okay, on the left side of the pump, we need to have this much pressure, and on the right side, we need to have this different amount of pressure. So if you were that person, who I'm not going to name because I don't want to embarrass anybody, you need to understand that's not the way it works. I mean, you've got one pump, and that one pump puts out a certain amount of pressure. So you need to figure out, using that pressure, how much force would you, or how big would your piston have to be in order to get the right amount of force when you retract. Now, when you're pushing out, you're going to have more pressure because you've got more area. Because when you're pushing it out, the piston head, you get the pressure acting on the full piston head. Whereas when you're retracting, you don't get the full piston head because the shaft is kind of blocking some of that, right? So on the way out, you get more force, and on the way in, you get slightly less force. But it's going to be the same pressure on both sides. So you need to calculate what is the piston area that will allow you to have enough force when you retract, with the understanding that then when you push out, you'll have more than the required force. And that's okay. It's good to have more force than you need. It's not good if you don't have enough force. So please redo that one. And there's one of the submissions that I looked at that something went seriously wrong in your calculations somewhere. The numbers that you put are not even close to working right. So again, I'm not going to name any names right now. Later this afternoon, I'll go through and I'll put scores on each one of them, and I'll write you comments. But for the most part, most of you did pretty well. Okay, are there any questions from you about the assignment that was due today before I move into the new stuff? Not seeing anything, not hearing anything. Yeah.
So it really didn't matter which way we did it, whether we started with like if we choose our own diameter, we have to find the pressure. But if we choose our own pressure, we just go back and find what diameter we need. But it didn't really matter which one we chose, right?
You're exactly right. You can do it in
Okay.
either order. Yeah.
Okay.
All right. Okay, now, if this was a face-to-face class, if we were at the building at Ames, what we would do next is we would actually get some stuff. So as I showed you last time, okay, I have a bunch of actual cylinders that could be used either for pneumatics or for hydraulics. This cylinder couldn't care less whether you put air in it or whether you put liquid in it. It works perfectly well either way. And so now that you guys understand how it works, we would actually build some systems. Now, the systems that we build would not be hydraulic systems, simply because I don't want to mess with all that hydraulic oil. If you got any leaks in your system and that hydraulic oil gets out and it gets everywhere and it's just a horrible mess to clean up. So what we would do is we would take the systems that you designed, but instead of using them with liquid, we would use them with air. So we would have a pneumatic system rather than a hydraulic system, but it works the same. So the principles are exactly the same. So that's what we would do if we were in person. And hopefully the coronavirus, hopefully isn't going to last forever. And so at some point, if we're lucky, before the school year ends, we will take the designs that you guys submitted today, and we will actually build some systems, but not right now. What with coronavirus being what it is, we're going to have to put that on the shelf for a little while and come back to it later. Okay. But we are going to do something very similar to this. Okay. We are going to design something using materials that you have at your houses that use hydraulics to accomplish a job. And I think it's a worthwhile activity. I think you'll learn a lot from it. So those of you that have taken my physics class, you know that I like rockets. The rockets that we use in the physics class are solid fuel rockets made by a company called Estes. And so what you do is you light the rocket, and then a bunch of flame comes shooting out and the rocket goes flying up into space, or at least into the sky. It's a great project. I really enjoy it. Well, we're going to work with rockets here, but they're not going to be solid fuel rockets. These are going to be air-powered rockets. These are going to be rockets that are made out of paper. And so what we do is we roll it into a tube of paper, and we fold off the end on the top, and we leave the other end open. And we're going to cut some fins in here to help the rocket fly better. Okay. And then we're going to have a launching tube, which also is rolled up paper. And then what's going to happen here is we will put the rocket on the launch tube. And then now, if we were at Ames, what we would do is we would hook, actually, if we were at Ames, what we would do is we wouldn't use a paper launch tube. We would use a PVC plastic launch tube, and we would connect this up to a air tank, a high pressure air tank, very, very similar to what you guys just got through designing, where we have a pump. Only instead of being a liquid pump, this would be a pump for air. And so it pumps air up into a chamber. And so we have a chamber full of high pressure air. And then we have a valve, exactly like the valves that you guys used in today's submission, except that instead of being a manually operated valve, it's an electrically operated valve. So when you apply the right voltage, it opens up very, very suddenly. But it works the same way. Okay, and so then once that valve opens up, then the high pressure launches the rocket. So if we were at Ames, we would use that. But since I assume you guys probably don't have a high-powered air compressor at your homes, and you probably don't have electrically operated valves at your homes, so we're going to cheat a little bit. We're going to use this rolled up piece of paper as our launch tube. We're going to take the rocket, we're going to put it on there, okay? And then what we're going to do is your lungs are going to be the high pressure cylinder, and your mouth and your throat are going to be the valve. Okay. So then what you're going to do you're going to come back here like this, and then you're going to go and you're going to launch it like that. Okay. Now, the goal is to design a rocket that will go farther than any other rocket. And we're going to talk in a few minutes about the different variables that you as the engineer are going to play with in order for this to work. And before we do that, I need to tell you a little bit about how I made the rocket. Because if you don't understand how the rocket is made, then you won't understand the different variables. All right, so let me share my screen here. Okay. All right, so ignore what you're seeing right now. That's the physics class. Let me go back to the main dashboard. All right, so let's click on the engineering principles class. And then we'll go down to the bottom where we have assignments, quizzes, and tests. All right, and so now if we scroll down to the bottom here, you'll see a pneumatic rocket template, which, I didn't publish it, so you can't see it. Okay, so there now, it is now published. And while we're at it, let's publish this other one too. The date on that is wrong. Sorry, never mind. The date when I first wrote this, I was planning on doing it on September the 17th, and that has obviously passed. So I will go in later and I'll change that date, and I'll have it be next time we meet. What's today? Today is Wednesday. So we will meet again on Monday. So I'll change it so that it's due on Monday. But what you're going to have to do is a functional specification for the project that I'm about to give you. But before we talk about that, let's talk about this pneumatic rocket, the template here. Okay, so when you click on this thing here, it will take you to a PDF file that you can download. And it's a document that looks like this. Okay, it's just, and when you print it, what you will get is a piece of paper. This is what you will get. Now, some of you might say, but Mr. Hendricks, I don't have a printer. That's okay if you don't have a printer. You can just take a regular piece of paper. Just look on the paper. You'll see on the template here, there are 3 dotted lines. And those dotted lines are intended to be where we get out some scissors and we're going to cut on those dotted lines. So if you print out the template, then that's the easiest way. But if you don't have a printer, just kind of look at the template and figure out where those dotted lines are, and so that you can cut in those right places. Okay, so assuming that you do have the template, okay, so what I want you to do is take these dotted lines, and you'll notice that your printer can't go all the way to the end, so I'm going to extend those dotted lines out by pen. Okay, so now you should be able to see that the dotted lines now extend all the way to the edge of the paper here. And it says cut here. So what we're going to do is we're going to get some scissors and we're going to cut there. All right, so I'm going to go, and I'm only going to cut as long as the line is, at least for now. This turns out that's a variable. One of the variables that you can play with is, if you want, you can make the cuts longer or you can make the cuts shorter. This is one of the variables you're going to be able to play with, and I'll talk about that later. Okay, so now you can see I have these 3 cuts. Okay, now I'm ready to start making my rocket, except I haven't yet made my launch tube. So let's set this aside for just a minute. We need to make the launch tube. And as you saw before, it's just a piece of paper that's rolled into a cylinder here. So we don't have to do any cuts on that. So we're just going to take a piece of paper. Now, I chose to use green paper or colored paper just because it's easier for me to keep track of which one's the launch tube and which one's the rocket. In reality, they can both be regular white paper. All right, so what I'm going to do is I've got the long side and I've got the short side. I'm going to take the long side and I'm going to roll the long side, roll it along like that. Okay. So I now have a paper tube. But the paper tube is too big. The diameter of the paper tube is too big. All right, so you say, well, how do you know how big is the right size? A penny. Get a penny. And I want the diameter of the rolled tube to be the same as a penny. So I'm going to take this rolled tube and I say, well, that's too much. So if I put my thumbs inside there, I can roll it more tightly, or what I could do is I'd just roll it more tightly from the very beginning. It's easier if I do it on the tabletop here. So you can't see what I'm doing, but I'm just rolling it. Okay. Okay, so now I need to know if it's the right size. So I take my penny, I put it in here and I say, ooh, it's a little bit bigger than my penny. All right, so that's too much. If you wet your finger, it works a little better. Okay, so what I'm going to do then is I'm going to reach in here, I'm going to roll it, make it a little bit tighter. And then I have to do the same thing on the other side so it's nice and even. Okay, so now I've made it tighter. So now I take my penny and I look to see, perfect. Oh, that's exactly right. Okay, the penny just barely fits in there. Okay, if the penny didn't fit in there, then I would know that it's too tight. But if the penny just barely fits in there, then I know that we're good. Okay, now I'm going to hold this carefully with one hand while I take a tape dispenser. Might have been better if I'd done this ahead of time. Let's get a couple pieces of tape here. I probably should have done this ahead of time. Okay, and so now I'm going to tape my rolled up paper here. Okay, and maybe a third one wouldn't be better, or even a fourth one. Let's do a third and a fourth one. Okay, and so I'm going to put those in the middle right here. Okay, and now let's check to make sure that while I was putting the tape on there that it didn't slightly expand. So I take my penny again, and yep, okay, it just barely fits in there. Perfect. Okay, so I've made my launch tube, right? So that's the first thing we have to do before we can do the rocket. Right, now we're ready to make the rocket. We're going to use the launch tube to help us as we roll the rocket. So if you use my template, you'll see down on the bottom here, it says start rolling here. Now, if you use your own, if you don't have a printer, so you have to make your own, then okay, just know that you're going to start down here. So the cuts will be up at the top, and you start rolling from the bottom. Remember to make the cuts before you start rolling. All right, so what I'm going to do now is I'm going to use my launch tube as the guide, and I'm just going to start rolling the rocket around the launch tube, like that, okay? And then I'm going to keep on rolling. Now, one question that you're going to have is how tightly should you roll it? Well, it turns out that's one of the variables that you are going to play with. When we do the engineering design here, you're going to see that you have a bunch of variables you can play with to try and optimize your rocket. One of the variables is how tightly do you roll it when you put it on the launch tube. Maybe you want to roll it really tight. Maybe you want it to be really loose. I'll leave that up to you. Okay. So anyway,
Wait,
so I'm rolling.
Andrew,
Yeah, go ahead.
you cut out for all of us for like 10 seconds.
Oh my goodness, that's not good. At what point did I cut out?
You were starting to roll
You
up
just
the
started to
rocket.
roll up
When
the
you're
tube.
rolling up.
Okay, I just started to roll. Okay, so let's start again there. Okay, so here's my launch tube. Here is the paper that I'm going to roll, and I'm going to roll from the bottom, leave these up at the top. So I'm going to put this on my launch tube, and I'm going to start rolling. Okay. Now, the question hopefully will come up to your mind is how tightly should you roll it? Should you roll it really tight or should you roll it a little bit loose? Okay, that's one of the variables that I want you to play with when you're trying to optimize your design. Your goal is to come up with a rocket that will go farther than anybody else's rocket. And you're going to have a bunch of different variables, and I'm in a very few minutes here, we're going to talk about what the different variables are that you can play with. But one of those variables is how tightly do you roll it? Maybe it's best if you roll it really tight. On the other hand, maybe it's best if you leave it loose. It's up to you to figure out which. Okay, so now watch what happens as we roll it when we get to where these cuts are. So let me see if I can turn this in a way so you can see. Okay, so as I roll it and I get to the cut, do you see what happens there? The place where it cut, the paper rolls, but the cut part doesn't roll up. and now I keep on rolling, and now I'm at the second one, and now I keep on rolling, now I'm at the third one. And so now what I've got is I've got the fins of my rocket. Okay, pretty slick how that works out. Now again, I should have gotten some tape before I did this. Shame on me, but I think I can still do it. Okay, so I'm going to get a couple pieces of tape. All right, and hopefully I didn't let that go. All right, I think we're good. Okay, so I'm going to put a little bit of tape right here, and I'll put a little bit of tape in the middle, and I'll put a little tape at the very front of the rocket here, not at the very, very edge, because we're going to fold that over. So I'm going to leave it maybe an inch down. Okay, so now you can see why I used a different color for my launch tube, is so you can easily tell what's the launch tube and what's the rocket. You don't have to use a different color if you don't want, but I did because it makes it easier to understand. Okay, so now if I take it out, you'll see I have a rocket, and on this end right here, I have fins on my rocket. Okay, those fins serve an important purpose. When the rocket is flying through the air, you know, if the rocket gets a little bit off as it flies through the air, if it's got these fins here, those fins will help pull it back so that it goes in a straight line. So fins are probably a good thing to have on your rocket. Now, do you want big fins or do you want little fins? Well, hey, guess what? That's a variable that I'm going to let you guys play with. Okay, so you're going to experiment to see, is it better to have big fins, or is it better to have little fins? Or hey, maybe you might want to try a rocket without fins, without fins. Who knows? Maybe that would work better. All right. Okay. Now, if I try to launch my rocket now, so I'm going to take it, I'm going to put it on the launch tube, and I'm going to try to launch it. Not working too well. Why is my rocket not launching?
The air is escaping off the top of it.
Yeah.
Not sealed.
Yeah, my rocket's not sealed. Okay, so it's not going to fly very well unless I seal off this end. Okay, so what I'm going to do is I'm going to take the launch tube and I'm going to position it so that the launch tube sticks out about 1 inch from the tail end of the rocket. So that means that the rocket here is extending about 1 inch past the end of the launch tube. And what I'm going to do is I'm going to put my finger here and I'm going to fold it over. Okay, about like that. You see what I've done there? You got folded over. Now, in a minute, I'm going to fold it over the rest of the way, but before I finish folding it, I'm going to take that penny that I used as my measure for knowing whether or not the diameter of my launch tube was right. I'm going to take that penny and I'm going to put that right in here where I folded it over. Okay, so now I've got a penny inside there. Okay, and then now that the penny's there, I'm going to fold over the others, and this time I'm going to learn from my mistakes. This time, before I fold it, I'm going to get a couple pieces of tape all ready to go. Oh, these pieces of tape should be longer. Make them, I don't know, maybe 2 or 3 inches long. Okay, so that first one that I did there wasn't quite long enough. Let me get another long one here. Okay, so I've got a couple nice long pieces of tape ready to go. Okay, so now I come back to my rocket, and here's the front end, and it's got the penny all sitting in there nice and neat. Okay, and by the way, let's talk about it now rather than later. Another one of the variables that you have to play with is how much weight do you want to put in the nose here? So you could go with 1 penny, or if you want, you could put in 2 pennies or 3 pennies or 4 pennies. You can put as many pennies as you want in here. And in a minute, I'm going to talk about why you might want to have pennies in there. But that's another one of the variables you're going to play with. Oh, and if you want, you could leave out the pennies altogether. I mean, you don't have to use pennies, but you might find that it helps to have pennies. Okay, so right now I'm just going to put in 1 penny. So there's my penny. My penny's in there. So now that the penny's in there, now I'm going to fold over the rest of it here. Okay, and you got to be careful you don't crush your rocket when you do this. It's a little bit tricky, but it can be done. Okay, so I've got it folded over. Now I'm going to take my long piece of tape and I'm going to put it on here. And now you see why you want it to be long, because you want it to come down on both ends there. and I'm going to put one over one way, and then I'm going to come over and do the other one the other way. So let's do this one like this. Okay, so now my rocket, the nose of my rocket is now sealed. So now if I blow, it'll come out and it'll go flying really well. So now I've got a rocket. Okay, now if you look at the fins, you'll see that when the fins come out, they don't come out perpendicular to the rocket. They come off at a little angle. Now maybe that's okay. If you want to leave them like that, hey, more power to you. But if you want, you can fold them over a little bit and give it a little bit of a crease so that when you're done, now you'll see the rockets, the fins now are perpendicular to the rocket. So you don't have to do that if you don't want, but that's an option. Okay, I now have a completed rocket and it's ready to launch. So when I put it on my launch tube, off it goes, right? All right, so why do you suppose I put a penny in the nose of my rocket? Anybody got any ideas why that's there?
For weight on the nose of the rocket.
That is correct, but why would I want to have weight in the nose of my rocket?
To keep it flying straight.
Yeah, to help keep it flying straight. And Moses said, so to keep it balanced. Yeah, so as this rocket flies through the air, we want it to fly nice and straight. And rockets tend not to fly very straight. They tend to wobble. So the fins on the end here, they will help to keep it so it doesn't wobble, but also the weight in the nose serves the same purpose. If I have a lot of weight in the nose, then as it flies through the air, it wants to keep it straight. Now, some of you have had my physics class, but most of you have not. But in junior high school, you probably, or at least you hopefully, heard the word momentum, okay? So momentum is when you get something moving, okay? Momentum is what wants to keep it moving. The more weight it has, the more momentum it has, and the more it wants to keep moving. So as this thing is flying through the air, air is, there is something there. Air is not just emptiness. There are lots of molecules there. So as this thing flies through the air molecules are trying to slow it down. So the more weight it has, the more momentum it has, and therefore the less it's going to be affected by the air as the air tries to slow it down. So giving it some weight is a good thing. That will help it to fly better. But if you give it too much weight, that could be a bad thing. So think about it. How could too much weight be a bad thing? Okay, so when I go to launch this thing, so I'm going to blow on it. So I'm blowing on it. So the thing is sitting there at rest. And when I blow on it, I need to get it moving. So again, those of you that have had my physics class have an unfair advantage here. You know that there's an equation called Newton's second law that says F equals ma. So the amount of force that you need is equal to the amount of mass you have times the amount of acceleration it's going to get. So the more mass, or in this case, the more weight I have in the nose cone, the harder it is to start the rocket moving, okay? So if I put too much weight in the nose cone, when I go to blow, it's not going to move as fast as it would if it didn't have much weight in it. But once it starts moving, all of that weight there now becomes a good thing, because once it starts moving, the more weight it has, the more momentum it has, okay? So a little bit of weight is a good thing. Too much weight is not a good thing. So one of the jobs that you guys need to do is figure out how much weight is the ideal amount. All right, so that's one of the variables that you're going to play with. All right, so now that you know how the rocket is made and you know how the rocket is launched, you are now ready to start into the next project that we're going to do. And this is going to be the last project that we do that's from the aeronautical engineering unit. So you need to design a paper rocket that can fly farther than anybody else's paper rocket. All right, so we're going to follow the same pattern for this that we've done for the other ones. Every project that we follow all year long, we have to follow the engineering design process. So what is step number 1 in the engineering design process? Somebody help me out here.
Functional specification.
Right. Step number 1 is you have to understand what is the problem you're trying to solve. You have to understand what are the constraints that you have to work within. Okay? You have to understand how is the thing going to be tested. All of that is the stuff that needs to go into the document that you're going to produce, which is going to be tonight's homework, by the way. And that is a functional specification. Okay, so we're going to do this exactly the way that we did before. I am going to be the customer, and you are going to be the engineer who represents your engineering team. You work with a team, you know, a very large team of engineers. You've got dozens of engineers on your team. And all of those engineers need to know what the job is that they need to accomplish. But they can't all meet with the customer. That's just not realistic. You don't want to overwhelm the customer. You don't want to have one customer on this side of the table and 30 engineers on the other side. That'll intimidate the customers and not a good idea. Okay, so you are the one person who has been chosen from your team to meet with the customer and discuss the project with the customer. And then after you've asked the customer all the questions you need to ask, because you never know, the customer might accidentally forget to tell you a few important things, right? So it's your job to pull out all the important information from the customer. Okay, then once you've done that, you need to go back and write up a functional specification, which you will then give to your team members so that they can then sit down and start the brainstorming process and the designing process and all the rest. All right, so we're going to have the customer meeting right now. So I'm going to take off my teacher hat. I'm going to put on my customer hat, and let's start the meeting. Thank you for coming and meeting with me today. I have a project that I want you to work on. I think it'll be a fun and interesting project, and I'm hoping that your company will do the best job at meeting my needs here. So let me tell you what I need, okay? I need you to design me a paper rocket that will go farther than anybody else's paper rocket. Now, there are requirements on how this paper rocket has to be made, okay? And there are requirements on how it has to be launched. So first, let's talk about the launcher. And by the way, this is exactly what we've already talked about, okay? But, okay, so the launcher has to be a piece of paper, 8.5 by 11. Well, actually, no, maybe it doesn't have to be 8.5 by 11. I'll let you decide. But the diameter, that's important. You're not allowed to play with the diameter. The diameter of the paper roll has to be equal to the diameter of a penny. So that if you put the penny in there, the penny just barely fits. Okay, if the penny doesn't fit, then the roll is too small. Now, if the penny goes in and there's lots of room for the penny to wiggle around, then the paper is rolled up too loose. I need the roll to be exactly the right size so that when I put the penny in there, the penny just barely fits. Okay, and then I want you to tape along the edge here. And so that is the launch tube that you have to make. Now, you don't have to make it so it's 11 inches long. If you want to make a shorter launch tube, I'm okay with that. If you want to make a longer launch tube, if you want to take 2 pieces of paper and put them together, hey, I'm okay with that. The only thing that's important to me is that it has to be made of paper and the diameter has to be the same as a penny. Okay, so now once you've made the launch tube, now I want you to design your rocket. And the rocket needs to be the right size so that if I put it inside my launch tube, okay, so if I put it in the launch tube like that, okay, it fits in the launch tube so that when I blow, or when you blow on the launch tube, the thing goes shooting off, okay? So the rocket needs to be rolled around the launch tube. Now it's up to you to decide whether you want to roll the rocket really tight or whether you want to roll the rocket really loose. That's up to you. I don't care. Okay. And now the rocket has these fins on it, and you guys know how the fins are made now, right? Okay, well, I, as the customer, I don't really care about the fins. I'm going to totally leave that up to you. If you want to put fins on there, fine. If you want small fins, if you want big fins, I don't care. In fact, I don't even care if you have no fins at all. That's just something that you might possibly want to put on there. I'll leave that up to you. Okay. Now in the nose of the rocket here, if you want to put some weight in there, you're welcome to do that. And I'll let you choose how much weight you want. I recommend that you use pennies, but actually I don't require that you use pennies. You can put whatever you want in there. Or if you want, you don't have to put anything at all. It's up to you how much weight, if any, you want to put in the nose cone. And okay, so now once we got these rockets, what you're going to do is you're going to use the launcher and you're going to launch the rockets. Now, ideally, I would prefer to launch these by having a pressurized tank of air, and everybody's rockets would be launched using the exact same air pressure. That's the fair way to do it. Ideally, that's what we would do. But because of coronavirus, we can't do it that way. So what we're going to have to do is I'm going to have to allow you to launch it by blowing into the tube here. And I recognize that some people can blow harder than other people. Some people are what we call blowhards, and I won't mention any names, okay? But some of you are definitely blowhards. So those of you that are blowhards, you have an unfair advantage. Hey, what can we do? All right. So bottom line, I want you to design me a rocket that goes farther than anybody else's rocket. Okay, so are there any things that you can think to ask that I might have accidentally left out?
Does the material of the paper for the rocket matter?
Okay, I can see how that might be important. Yes, there are different types of paper, different weights of paper, right? You know that there's a certain kind of paper called cardstock. You may have seen. It's really thick paper and it's hard to roll. But if you want to use cardstock, I'm okay with that. Also, there's a kind of paper that's super thin. It's called, I could think of the name just a second ago. It escaped me, but really thin paper. Yeah, if you want to use really super thin paper, yeah, I'm okay with that. Okay, Gladys is asking, are you able to do more than one design? Yes, okay. In fact, I want you to make at least 3 different prototypes. And you guys remember what the word prototype is, right? So I want at least 3. Now, if you want to make more than 3 prototypes, I'm okay with that. But I want at least 3 prototypes, and each of the 3 prototypes is going to be different in some way. You know, maybe one of them has big fins and the other has small fins. Maybe one of them has a lot of weight in the nose and the other one has very little weight in the nose. You know, I'll leave it up to you. But yes, I want at least 3 different prototypes. I want you to test the 3 different prototypes and see which one flies best. Yeah, so yes, Gladys. Any other questions?
So are we measuring vertical height or horizontal height? Length,
When you
I mean.
when you measure how far it goes?
Yes.
Okay, yeah, that's an important thing that I accidentally forgot to mention. Yeah, so I care about how much horizontal distance did it go. The vertical height is really hard to measure, so I'm not going to worry about that. So, and you can aim it at whatever angle you want. You know, if you want to go 45 degrees or 50 or 30, you know, you get to choose the angle, but it's going to fly through the air and then it's going to land. And so the number that I'm going to use to determine who did the best job is the distance from where you were when you shot the rocket until where the rocket lands. Okay, that is going to be really important. Now, some of you are going to wonder, well, can we do it outside? My answer to that is you're going to have to do it outside because uh, when I've done this project previously with other students, they've built rockets that can go really, really far. And I'm sure that nobody has a house big enough to where you're going to be able to shoot this rocket inside and not have it hit the wall. So yeah, you're going to have to go outside in order to test this. So I recommend you do it on a day when there's no wind, because the wind's going to mess everything up. In fact, let me require that you have to do it on a day that there's no wind. Because if you wanted to cheat, you could go out there on a windy day and you could stand with your back to the wind and you could launch it that way. And then the wind would help it go farther. That would be cheating. Okay, so requirement must be a windless day when you test it.
How low of wind speeds is windless?
It just feels windless. I mean,
All right,
I'm
that's because that's just kind of I was just kind of curious because
yeah.
like there is always air movement and so
Yeah, it's unavoidable. There's always going to be some. So yeah, I'm not going to put a spec on what the wind speed has to be. Just on a day that feels like there's no noticeable wind. Any
Can
other
the launch can the launcher only be, can we connect several pieces of paper to make the launcher, or can it only be one piece of paper?
Okay. You can do what you just said. So this launcher that I made it from a piece of paper that was 8.5 by 11, and then I rolled it on the long side. So this launcher here is 11 inches long. But you could take two of them and tape them together so you have a longer one. That is okay. And by the way, if you want to go the other direction, maybe you don't want one that's 11 inches, maybe you only want one that's 5 inches. So the length of the launcher is okay, and it is okay to take multiple sheets of paper together and connect them that way. That is okay. And by the way, let me just go with the follow-up. At no time did I ever tell you how long the rocket needed to be. So you can do the same thing with the rocket if you want. If you want to take two pieces of paper, or three or four, okay, and tape them together so that you have a super long rocket, that's okay. Or maybe you might want to make a short rocket. Maybe you don't want your rocket to be 11 inches long. Well, maybe you only want your rocket to be 5 inches long. That's okay. The length of the rocket is up to you. The only thing I care about is the diameter of the launch tube has to be equal to a penny. And then that launch tube is where you're going to use to launch the rocket. So if the rocket isn't at least somewhat close to that in diameter, you're going to have a little trouble launching it. Any other questions? Okay. So Moses is saying, do you measure from the bottom of the rocket or the top after launching? Okay. So when you launch the rocket and you measure the distance, you're gonna start from where you are standing. Okay. So just kind of maybe in your mind, kind of draw a circle on the ground, and then you stand so that you're in the center of that circle as much as can be. And then you're going to measure from the center of the circle where you are standing to where the rocket hits. And by the way, when the rocket hits, it might bounce. Now, if it hits on the grass, it's not really going to bounce very much. But if it were to hit on some slippery surface, the rocket might possibly slide for a while after it bounces. So I'm going to do this one differently than I did for our paper airplane. This time around, I'm interested in where does the rocket first hit the ground. If it slides or bounces after that, don't count any of that. So you're probably going to need to have your little brother or sister, or maybe your big brother or sister, or maybe your friend. You're going to have somebody else help you so they can stand there and they can identify where does the rocket first hit the ground, because that's what I'm interested in. Any other questions?
Some people are just taller in general, so what about like the height from where they shoot it from?
That's an important question. You obviously know something about physics. So Zaid has an unfair advantage over the rest of you guys. He knows physics because he took physics last year. So you are correct, Zaid. A taller person does have an advantage over a shorter person. How can we get around that? Let's say that if you are one of the shorter people, it's okay for you to stand on a box. So let's say that the maximum height from which you can launch your rocket is 6 feet. If you are taller than 6 feet, then you're going to have to stoop over. If you're shorter than that, then if you want to stand on a box, that would be allowed. Okay. You don't have to. I mean, if you want to launch it from 5 feet or from 4 feet even, that's okay. You don't have to launch it from 6 feet, but you cannot launch it from anything higher than 6 feet. And by the way, let me go with a follow-up idea. When you shoot the rocket, you need to be on level ground, or at least as level as is reasonable. If you're standing on top of a hill and you shoot the rocket down the hill, that would be cheating. Okay, so find a level ground and launch it from there. Okay, so Gladys is asking if there's a certain number of times you want to record the testing. Okay, very important question, Gladys. All right, I only want one video. And by the way, I do want a video, okay? And I don't care how many times you do it. I mean, if you want to do 100 launches and then pick the one best launch out of that 100, and then send me a video of that one best launch, that would be okay. In fact, that would be what I want. I do not want 100 different videos. And I also don't really need 3 different videos. I just need one video of whatever is your best launch. Now you're going to make 3 prototypes, but you don't have to videotape all 3 of those prototypes. You're going to test all 3 of the prototypes without video recording them, and then find out which one of your 3 prototypes is the best. And by the way, after you've tested your prototypes, if you then want to make a 4th or a 5th prototype based on what you learned from your first 3 prototypes, if you think you can do better, yeah, go back and do better. You can do as many prototypes as you want, as long as you do at least 3. Okay, so you need to describe the 3 prototypes, but you only need to take video of the one that's the best. Okay, does that answer your question, Gladys? And you only need to do 1 launch. You don't have to, last time I wanted you to do 3 throws and you averaged the 3. This time I'm not going to require that. Just 1 throw or one launch, and whichever launch is your best, that's the one to go with. I am going to want an engineering specification, yes. Yes, for sure. But tonight, don't worry about the engineering specification for tonight. And in fact, for tonight, you don't even need to make the rockets tonight. That will be next time we meet. Your assignment for tonight is just to write up the functional specification, nothing else. Now, if you want to get a head start, you have my blessing. But the only thing that's due next time we meet is the functional specification only. Okay, any other questions?
So can we only use tape or can we use glue?
Okay, thank you for asking. Yeah, let's say tape only. Okay, only tape. Now, let me follow up on there. That brings up a question that some of you may want to know. What kind of tape are you allowed to use? Okay, well, I'm going to leave that up to you. Okay, so you'll see the tape that I used is what's called Scotch tape. You guys may know that there is other kinds of tapes. See this here, this is called painter's tape. If you want to use painter's tape, that would be okay with me. That would be a great variable for you to play with because Scotch tape is nice and smooth. Painter's tape is kind of rough. And so depending on which tape you use, that might possibly make a difference in your rocket performance. Okay. Any other questions? Right, I'm not hearing any. Okay, there I am seeing one. Okay, so Dylan is asking how much tape can you use, right? The answer is that's up to you, okay? So on your launcher, if you just want to put one piece of tape on this end and one piece of tape on that end, fine with me. If you want to put tape all the way along the edge there, that's fine with me too. If you want to coat the entire surface with tape, even the parts where you don't really need tape, okay, but if you wanted to, you can use as much tape or as little tape as you want, but you can't use glue. It does have to be tape. Okay. Any other question?
We can shoot it at any angle, right?
Yes. Okay.
Okay.
And again, here's where Zaid has another advantage over you guys, because Zaid knows physics. Zaid happens to know that the angle you shoot it at makes a big difference. In fact, tell you what, Zaid, because I don't want you to have too much of an unfair advantage, can you use your physics knowledge right now and tell us what angle is going to give them the best distance?
Probably a 45-degree angle.
Yeah. Now, if I really got nitpicky, what you would find out is that if you shoot it from ground level, and then it flies through the air and then it hits a ground level. So if you were launching it from ground level, then for sure 45 degrees is the angle that'll give you the best. It turns out that if you're launching it from above the ground level, so it starts off at say 6 feet above ground level, okay, it turns out that the ideal angle in that case is actually not 45 degrees, okay? But it's gonna be so close to 45 that I would say don't worry about it, okay? So I would recommend that you launch all of your rockets at 45 degrees. But if you don't want to use 45 degrees, you don't have to. It's totally up to you. Any other questions?
So there's no max length for the launcher then, right?
That's correct. There's no max length for the launcher.
Okay.
And again, Zaid, you've just got so much of a unfair advantage over everybody. There's a reason why Zaid asked that question, because Zaid knows, because of his experience in physics last year, Zaid knows that the length of the launcher actually does make a difference. Okay, I'm not going to say any more on that. Okay. Okay, so Dylan is asking if there's a maximum weight for the rocket. The answer to that is there is no maximum. You can do whatever you want. Okay, I'm not seeing any more or hearing any more questions, so let's call it good. All right, so I'm going to take off my customer hat, put back on my teacher hat again. All right, so your homework assignment tonight is just write up a functional specification. Now, I'm going to be a little bit fussier this time than I was last time. Last time, some of the functional specifications that you guys turned in were not very complete. And I gave you most of the points on it anyway, because I figured, hey, it's your first time around. I'll be lenient. Well, it's not your first time around anymore. Okay, so let's make sure we understand what needs to be in a functional specification. Okay, what is the goal of the project? Okay, what materials are you allowed to use? What materials are you not allowed to use? How are you going to test your final creation? How are you going to measure success with your final creation? Those are all things that need to be in the functional specification. So if you turn in functional specifications that are not very complete, I will take off points. Okay, I want to see all of those in the functional specification. Now, what is it that should not be in a functional specification? Well, any hint as to how you intend to do the project should not be part of your functional specification. So like, for instance, if you say, well, I think I'm going to make some big fins here. I think that's going to help me. Well, don't talk about that in the functional specification. Okay. You say, well, all the other variables we talked about, weight in the nose and length of the rocket and all that kind of stuff like that. Yeah, save that for the engineering specification. For tonight's homework, it's just a functional specification only. Okay. So everybody understand what the assignment is for tonight? Okay, I see some thumbs up. All right. Okay, well then, I think we're done for the day. Now, that doesn't mean the class is over. We still have, how much time? We still got 20 minutes left of class time. So I want you guys to use that 20 minutes to write up your functional specifications. That 20 minutes should be more than enough time to do that. So then if you finish that and submit it, then hey, your homework will be done. All right. So do you guys want me to stick around online while you do that, or are you okay if we just end the meeting here? I kind of get the impression that you guys got a good idea on what needs to be done. All right, so tell you what I'm going to do. Let's end the meeting. So guys, please make sure you type bye into the chat box. Otherwise, you may not get credit for being here. So I'm going to go ahead and stop the recording.